Another question that was asked by a brother on Telegram channel of Econ Maths was like this. The demand function for museum tickets is given by Q is equal to 500p to the power minus 1.5 and marginal cost is $3. How much should tickets to be priced to maximize profits? Okay, we need to find the profit maximizing level of price. The options are $9, $4.71, $6 or $12. Okay, let us see how to find this. So we are being given, let me write it here, profit maximization, as I have shown you n number of times, requires that our marginal revenue should be equal to the marginal cost. Okay, now how do we find marginal revenue? We find it from total revenue. And how do we find total revenue? We need to find P into Q. Okay, simply now we have here Q is equal to 500 p to the power minus 1.5, and this can be written like this: Q is equal to 500 upon p to the power, now 1.5, let me write it here, 1.5. Okay, or if we transpose this here, so p to the power 1.5 is equal to 500 upon Q. Okay, now what is p to the power 1.5 can be written like this: p to the power 3 upon 2 is equal to 500 upon Q. Okay, or if we transpose this exponent, the exponent will get reciprocated in the RHS. Okay, so p is equal to 500 2 upon 3 divided by Q to the power 2 upon 3. Okay, simple thing, you know how to do it. If I can show it here, so we have p to the power 3 upon 2 is equal to 500 upon Q. So I'm just explaining how did I get this. So this could have been written like this: 500 upon Q raised power, transposing this, the exponent sign gets reciprocated, this becomes 2 upon 3. Now this 2 upon 3 is exponent to each of the numerator and denominator, so this will come out to be 502 upon 3 divided by Q to the power 2 upon 3. Okay, so I am just explaining the kapera. Okay, let me rub this out now. Now this is our inverse demand function. What is now total revenue? Total revenue is simply price into quantity. What is price? Price is this very stuff. So we have 502 upon 3 upon Q to the power 2 upon 3. To this we multiply quantity, that is Q. Now we can write it like this: we have 500 2 upon 3 Q into Q to the power minus 2 upon 3. Simply transposing this numerator to this denominator to numerator, the exponent sign gets changed. It was plus 2 upon 3, it becomes minus 2 upon 3. Okay, since here bases are same, we can add up the exponents. Simple panda here. So we have, now this comes out to be 1 minus 2 upon 3. You go, I see 3 is the arc. Okay, 3 minus 2 is 1 upon 3. Okay, so we are left with 502 upon 3 and Q to the power 1 upon 3. This is our total revenue. Marginal revenue, as I have told you, the derivative of total revenue with respect to quantity. So taking derivative here, so our choice variable is Q to the power 1 upon 3. The derivative of Q to the power 1 upon 3 is this 1 upon 3 will become the exponent first. Then we have 500 to the power 2 upon 3 Q to the power. Now this exponent is subtracted by 1 by the power function rule. Now what is this? This is simply 1 minus 3. This comes out to be minus 2 upon 3. Okay, this is our marginal revenue. What is our marginal cost? Marginal cost is $3. Now profit maximization requires our marginal revenue should be equal to the marginal cost. Our marginal revenue is this very stuff. So this can be written like this: 1 upon, let me write it like this: we have 500 2 upon 3 divided by 3 into, transposing this to denominator, it will become Q to the power 2 upon 3 should be equal to the marginal cost, which is 3. Okay, Now 1 upon q to the power 2 upon 3 is equal to, we have 3. If we transpose this, it will get reciprocated, so 3 comes up. We have 500 sorry 502 upon 3. Okay, I hope I am making myself clear. So we can write it like this. This becomes q to the power 2 upon 3 is equal to 9 upon 502 upon 3. Now what we can do, we can do one thing here. If we transpose a numerator to denominator on both sides, so there should be no problem. So if we reciprocate both the LHS and RHS, so we can write it like this: q to the power 2 upon 3 is equal to 502 upon 3 divided by 9. Okay, or q is equal to now transposing this exponent, it will get again reciprocated. So we have 500 upon 9, so this is 2 upon 3 whole power. 2 upon 3 will become 3 upon 2, and this can be written like this. We have 500 2 upon 3, then we have 3 upon 2 to this 9 can be written as 3 square 3 upon 2. Okay, here 3 3 2 2 gets cancelled. 2 to 2, we are left with q is equal to 500 upon 3 3s are 3 3s are 9 3s are 27. Okay, so just plug this value in the inverse demand function, in this demand function, to get the price. Okay, so if we put q is equal to 500 upon 27, let us see what we will get. The equilibrium price, that is p is equal to, we have 500. Okay, 500. Am I doing the calculation right here or not? So I got the value of q. Q is equal to this. So price will be equal to 502 upon 3 divided by the value of q is this 500 upon 27, and it is like this 2 upon 3. Okay, so let me rub something here. I cannot rub this out, so let me write like this. Our p is equal to 500 raised power 2 upon 3. Okay, divided by, we have this 500 raised power 2 upon 3 divided by 27 can be written as 3 cube raised power 2 upon 3. Okay, so let me wrap this first here. I am getting confused. So we have p is equal to 500 raised power 2 upon 3 divided by 1. Taking this term to a numerator, it will get reciprocated. This 3 and 3 will get cancelled, so we are left with 3 square upon 500 raised power 2 upon 3. This step gets cancelled. We are left with p is equal to 3 3s are 9. That means profit maximization price should be equal to 9, and I hope yes, 9 is in the options. Okay, I hope I make myself clear in this video. If you like these videos, please share with your friends. Okay, so we were being given an a demand function. First we need to find the inverse demand function. How do we find the inverse demand function? We need to solve this very demand function for p, and I explained it here in great depth how to do this. Okay, so The only motivation that will keep me going on will be that if you share and subscribe this channel. Okay, I have seen actually 91% of the people who view this channel, they just left without any subscription button being pressed. Okay, so please help in this regard. Thank you.